Whoa. Alright, so the reciprocal functions. First, when you think of a reciprocal, normally you think of a fraction, and if you had a fraction, what would be the reciprocal of 7 over 25? 25 over 7. You would just flip it, right? What if it was a whole number? Like if it was 2, what's the reciprocal of 2? 1/2, okay? So with the reciprocal functions, if you have the sine of theta, the reciprocal is 1 over the sine of theta, and this has a special name, okay? It's the cosecant, and this is the abbreviation. And that's what you guys have in your chart. So the reciprocals of the sine, the cosine, and tangent ratios are also trig ratios, and they are called the cosecant, the secant, and the cotangent. So the first one that we're looking at the cosecant is abbreviated as your CSC. Okay, and then the cosecant is going to be the hypotenuse over the opposite. Okay, so before we had O over H, we just flip it. Okay, so again, if sine of theta is O over H, the reciprocal, the cosecant, is H over O. Okay, so in the margin, I'm just going to write that abbreviation. Okay, so this would be H over O. Okay, now the secant is one over the cosine, so that's going to be H over A. And then the cotangent, which is generally the easiest to remember, is A over O. Okay, so I remember the cosecant goes with the sine because this one starts with a C and this one starts with an S, so they have to start with the opposites there. Okay, and then this one, you have a S and a C. Okay, so cosine and secant, that's how I remember, are the opposites. Okay, now the cosine, the sine, and the tangent, they have SOHCAHTOA, right? That's how we remember it. Okay, and then for these, I say that I remember it by saying ho, ha, ayo. But really, you're just going to use the SOHCAHTOA. But that's fun to say out loud. You guys want to try it? You guys didn't know. Ho, ha, ayo.
Ho, ha, ayo.
Oh, yeah, it's fun. Alright, so, really, you're just going to take the reciprocal, but it's fun. So the Pythagorean theorem is something that you guys remember. In a right triangle, what's the Pythagorean theorem? A squared plus B squared equals C squared. Or you could say C squared equals A squared plus B squared. Okay? Now, the important thing is we know that A and B are the legs. C is the hypotenuse. A and B are interchangeable because they're both legs. So we're going to draw a picture that represents the Pythagorean theorem. Okay? So anytime you have the Pythagorean theorem, you have to put in your right angle. So remember that symbol. And then you can decide. You could put A here, and then B is the base, and C is the hypotenuse, or your right angle can go the other way, and maybe you want A as the base and then B on the side. The important thing is just that C is your hypotenuse. Okay, so for our next example, we're going to find the values of the 6 trig functions for theta. So on the front, we just did the sine, the cosine, and the tangent. Now we're going to do all 6. Okay, and then for B, we're actually going to cross this off and write B. So step one, you're going to solve for the missing side. Okay, so find out which side is missing. In this case, it's the hypotenuse, it's the C value. Okay, so we're going to do 70 squared plus 24 squared equals C squared. Okay, so then let's find this. So do 70 squared plus 24 squared. Tell me what the sum is when you did it. And so in your calculator, you can do the 70 squared plus 24 squared. Yes. Do you guys use the square shortcut here? Good. Because it's very helpful. Okay? Alright. So once you've gotten that, how do you find C? Yes, take the square root. Now, sometimes the square root will be a perfect square. That means this answer will be a what? It's a perfect square. A whole number. And then if it's not, then we're going to write it in simplest form. Okay? So take the square root, tell me what you get. Yeah. So 5,476 is a perfect square. Okay, now we are ready to find our ratios. So we're going to start with the sine. Okay, so your sine of theta. Okay, so theta is right here. So I'm going to label mine the opposite. This one is the hypotenuse, and this one is the adjacent. So remember, the hypotenuse and the adjacent side always should make the angle that you're using. Okay, so this is the opposite over the hypotenuse, and then I just have to reduce. So what goes into both 70 and 74? 2, so just cut it in half. So 35 on top, 37 in the denominator, and that is your sine of theta. So like I said, I make my theta like a little fancy here. I just like to do it at one time. You can just put a 0 and a line through it is fine as well. Okay, and then you have the cosine of theta. Okay, and that is the adjacent over the hypotenuse. So your adjacent is 24, your hypotenuse is 74, and then reduce. Again, these are both even numbers, so you know you can cut them in half. And you always want these in simplest form. Okay? Alright, and then the last one is the tangent, so that's your opposite over the adjacent, 70 over 24. So 35 over 12, and that is your tangent. Okay, now we talked about the other 6 ratios are reciprocals. So once you've reduced them, now you can find the cosecant, which is the reciprocal of sine. So this would just be 37 over 35. Okay, and then the next one is the secant. What would that one be? 37 over 12. Okay, and then what is the cotangent of theta? Yes. And again, make sure you have your theta every time. That is something that I would mark you down for on your quiz if you don't have the proper notation, okay? So you can't take the trig function of nothing. It always has to be of an angle measure. Okay, now for B, again, step 1, let's use the Pythagorean theorem. So this time, we're solving for one of the legs. So this would be 3 squared plus b squared equals 3 root 10 squared. We were doing that PSAT prep yesterday where we had to do something like this. Remember, without our calculator? So what's 3 squared? 9. Root 10 squared is 10, so this side is 90. So you have 9 plus b squared equals 90, which means that b squared is equal to what? Yes. So take the square root, and again, we have a perfect square, which is nice, but remember, maybe you'd have to solve for the hypotenuse in this one. So if you get a decimal, you always want to write this in simplest form, okay? Okay, that's called simplest radical form. So like I said, there's a lot of geometry stuff coming back. All right, so let's find the trig functions. Let's see if you guys remember what to do for this. So you have the sine of theta equals, so again, find where your theta is. Sometimes it's going to be in this corner, but other times it might be in this angle. So you always label based on where your angle is. Okay, so you would also have the right angle marked there. Okay, so the right angle across from that is your hypotenuse, and then I always like to do the opposite next, and then my adjacent. Okay, so this would be 3 over 3 root 10. What's your first step to simplifying there? Yeah, you can cancel out the 3's. 3 divided by 3 would be 1 over root 10. And then you don't square it, because that would change the value, but if you have a radical in the denominator, you can multiply. Yes, multiply by the bottom and the top, because that's like multiplying by 1. Okay, so the sine of theta would be root 10 over 10, and that would equal the sine of theta. Okay, now we're going to jump to the cosecant right from this, and I'm going to show you the quickest way to do it. So the cosecant is the reciprocal, but if you were to flip this, you would have to rationalize it again, and it's going to be a lot easier to look back here. Okay, if you were to take the simplified fraction, which is this, and do the reciprocal, what's the reciprocal of 1 over root 10? Yeah, root 10. Root 10 over 1, which is root 10. Okay, so this is just going to be root 10. So when you have the square roots, it's a lot easier to do the sine and then the reciprocal, the cosecant. Alright, so let's set up the cosine. And really, once you've done the sine, you know that both of these are over h, so you should always have the same denominator. And then the numerator is the adjacent side, which is 9. And then let's simplify that again. See how you can do 9 over 3? What's 9 divided by 3? 3, so it would be 3 on top over root 10. Okay, and then we just have to rationalize it. So we're going to multiply the top and the bottom by root 10. So we get 3 root 10 over 10 equals the cosine of theta. What questions do you guys have for me about simplifying with the radicals? Alright, so you guys are feeling good about that? Alright, let's do the reciprocal then. What's the reciprocal of cosine? The secant. Yep, and then so I would just go back and say, alright, this is what my reduced cosine was before I rationalized, so we just have to flip it. So it would be root 10 over 3. Okay, that is the quickest way to do it. You could flip that over and then simplify by multiplying by root 10 over root 10, and you would end up with the same thing when you simplify. Alright, and and then we have the tangent, so tangent, opposite over adjacent, so 3 over 9, and that reduces to 1/3. So that's your tangent. No radicals in that one. And then what's the reciprocal of 1/3? 3. So your cotangent is just 3. Alright, what questions do you guys have for me on the sine, cosine, tangent, or the reciprocals? Yep.
What are we gonna get a quiz back?
They're not even graded yet, and not everybody's taking them because SSC changes. So they'll finish taking it next week, and hopefully I'll get back to next week then. Alright, and then, I want you to, so what we're going to do here, we're going to have to recall something from geometry that we're going to write on the back. So we go to the back side of your packet. Okay, so we're going to remember some of our rules about special right triangles. Does that ring any bells?
Yeah.
Do we know what one of the special, or both of the special right triangles are? There's 2 of them. Well,
Wait, like the degrees of them?
yeah.
45.
Yeah, 30, 60, 90 I heard. And then the 45, 45, 90. So special right triangles. And one of them is isosceles. Do you guys know which one it is? No?
No, it's 45.
The 45, 45, 90 because they have, yeah, the 2 of the sides have the same length. Yeah. Okay, so for the 45, 45, 90, okay, we're gonna draw the triangle here. Alright, and it sounds like you guys, some of you remembered that these 2 are the same length, right? It's because if these 2 angles are the same, the sides across from them have to be the same. It's the Assassin's Triangle theorem, okay? So we are gonna give them a side length. So the side lengths here, we're gonna give them the most basic side length, 1 and 1. Okay, now, do you guys remember what the rule was that you talked about with the 45, 45, 90? It was the hypotenuse was equal to something. Do you guys know what it had to do with, even if you aren't sure what the, no? It had to do with the 2, it was the square root of 2. So it was the hypotenuse was equal to whatever the leg was times the square root of 2. Does that seem familiar or no? Okay, so if the leg is 1, 1 times the square root of 2 is just what? Square root of 2. Okay? So this is what you learned last year. Okay, this is, actually I think you did this as well. You had to find the sine, the cosine, and the tangent using special triangles. I remember it like it was yesterday. Okay, so you had to find the sine of 45 degrees using this triangle. Steph, you remember that, right? Okay, so you have to use the sine. You guys all remember it, right? I'm kidding, I know it's been a while, but let's think about how we can do this. If we're doing the sine of 45 degrees, right? If here's your 45, okay, sine is what over what? Opposite over hypotenuse. So what's my opposite side? 1. What's my hypotenuse side? Yep, so this would be 1 over root 2. And we can't leave it like that, so we have to multiply by root 2 over root 2. Okay? So the sine of 45 degrees is root 2 over 2. We had to find the exact value. Okay, and then the cosine of 45 degrees. Well, the cosine, if I do the adjacent over the hypotenuse, the adjacent is the same thing as the opposite, right? In this triangle. So the adjacent side is what value? 1. The hypotenuse is still root 2. So if I were to simplify, and you guys are going to get very good at just knowing, yeah, if it's 1 over root 2, that's going to simplify to root 2 over 2, and that is the cosine of 45 degrees. And yes, they are the same for a 45, 90 triangle. The last thing we're going to find is the tangent of 45 degrees. Okay, so we're going to do the opposite over the adjacent. Will you write that down on your paper? The opposite over the adjacent, and then simplify it. Okay, so Dylan, what'd you get for your opposite over adjacent?
You would just do 1 over 1.
Yeah, just 1 over 1, right? Okay, and 1 divided by 1 is 1. Okay, so the tangent of 45 degrees is equal to 1. Okay, so we're gonna be using that today. We're gonna be using these values today. We're also gonna be using them heavily in a couple weeks. Okay. All right. So you guys told me the 45, 45, 90 was one of the special triangles. The other one is the what? Yes, 30, 60, 90. Okay, so the 30, 60, 90. Okay, so the 30, 60, 90 had a short leg and a long leg and a hypotenuse. Okay, so the short leg was across from the 30-degree angle. The longer leg was across from the 60-degree angle. Of course, the hypotenuse, which is the longest, is across from the right angle. Okay, so you have the short leg. We're going to make that value 1 because we found the other values using the equations. Do you guys remember what any of those are? You guys remember the hypotenuse relationship to the short leg? That's the one that's double. So the hypotenuse is 2 times the short leg, which I think is what Caitlin said. Okay, so you have the 2 times the short leg. So if this is your short leg, what's the hypotenuse going to be? 2. You guys remember the other one, the long leg? Yeah. Square root, it's the square root of 3 and it'll be multiplied by it. So it was the square root of 3 times the short leg. Okay, so that means if you do 1 times root 3, you get root 3.
Oh, I remember that one.
Yeah. Alright, so what we're going to do is we're going to find the sine of 30, but also the sine of 60. So the sine of 30 degrees. So from the 30 degrees, the 1 is the opposite. Okay, and this is the adjacent, and this is the hypotenuse. So for 30 degrees, the sine of 30 is what over what?
1 over 2.
Yes, great. 1 over 2. Now, if you're going to do the sine of 60 degrees, remember that things are going to change. So from 60 degrees, okay, this side is the opposite side, and this side is the adjacent side. Okay, so now when you're doing the opposite, it's going to be root 3 over 2. Alright, so let's find the cosine of 30 and then the cosine of 60. Okay, so go ahead and write it down. So cosine is adjacent over hypotenuse, so do that for both of them. So for 30 and then for 60. Okay, I'll give you a minute to do that, and then you can do the tangent. Is there anything special you noticed about them?
The cosine of 30 is the sine of 60.
They're opposite.
The cosine of 60
Not for these. Alright, so yeah, the sine of 30 and the cosine of 60 should be the same. The cosine of 30 and the sine of 60, those are the same. How did we do with those? Finding them. Adjacent over hypotenuse. Good? Okay, so then for the tangent, you do opposite over, oh sorry, we're not doing theta, we're doing 30. I'm writing it over again. So the tangent of 30, okay, so for 30, you do the opposite over the adjacent, so 1 over root 3, but then we have to simplify that. If you simplify it, what do you get? Root 3 over 3. Good. Okay, and then for the tangent of 60, okay, from 60 degrees, you do the opposite over the adjacent, which is root 3 over 1. Root 3 over 1 just simplifies to what? Root 3. Okay, great. So, in the next example, we're going to have some values where we're not going to use a calculator. We're going to be using these values. And then if it's not a special right triangle, we're going to be using our calculator. Okay? Alright, so example 3, we're going to use a trig function to find the value of x. Okay, so for A, just do your best on the drawing. Okay, you have a right triangle. And this angle is given as 30 degrees. Okay, you are also given this is 74, and this length is x. Alright, so when you're solving, the first thing I like to do is find what angle I'm given, and then label the O, the A, and the H from that angle. So if this is 30, I know this is the opposite side. This is across from the right angle, so this is the hypotenuse. So if I have O and H, which trig function should I be using? Which one's going to have O and H? Yep, not the cosine. The sine is O and H, right? Opposite and the hypotenuse. So after you label, pick what trig function you want to use. In this case, it's the sine, because the sine of theta is O over H. Okay, and the only trig functions we're going to use for these are the sine, the cosine, and the tangent. You don't have to use the reciprocals. Okay, and then once you decide what function it is, you are going to set up the equation with your trig function. Okay, and then we're going to solve the equation, and when you do that, if you're using your calculator, you are going to have to be in a certain mode, so we'll talk about that in a minute. Alright, so this is the sine of, what's my angle measure? 30. So it's the sine of 30 degrees equals O over H. So x over 74. So to solve this for x, what would I have to do to both sides of the equation? Yep, if you multiply by 74, then that allows you to cross these off. Okay, so you will get that x is equal to 74 times the sine of 30. And sometimes I will just write the x on the other side, because we know that we're multiplying. Okay, now we actually know what the sine of 30 is. So if you had to do this without a calculator, all you have to do is look at the sine of 30. It's 1/2, so we can just substitute that in. So this would be 74 times 1/2. So half of 74 is 37. So that would be your final answer. Yeah. So that's because it's not in the correct mode. I'm going to show you how to do that for part C. And then we'll go back and check it, okay?
Quiz.
Yeah. For B, you have a 45, 45, 90. Okay, yeah, so if you did this one in your calculator, just wait a second, and I'll show you how to make sure you're in the proper mode. Okay, this is what you're given. Okay, so I want you to label and set up your equation. Okay, so label your O, your A, your H, and then see if you can pick out what trig function you're going to use for that.
Let's say 15 or 45.
Oh, yeah, yeah. Alright, what trig function did you guys use for this one? Yeah. Now technically this is a 45, 45, 90, so this is a special case where if you accidentally use the sine, it would be the same thing because it's a isosceles triangle. But your equation should be the cosine of 45 degrees equals x over 20. Okay, any questions with the setup? Setup is good? Okay, so this is the adjacent side, this is the hypotenuse. Okay, so then again, x is on the top, so you end up multiplying. This is 20 times the cosine of 45, so this is 20 times root 2 over 2. Okay, now to multiply with the square roots, you can think of this like over 1. Okay, what you're going to end up doing is 20 divided by 2, which is 10, so this is 10 root 2. Okay, now if this was a question where they asked you to round to the nearest tenth, and if you did this on your calculator, you would get that this is approximately 14.1. Okay, and then for part C, I am going to show you how to use your calculator for problems like this. Okay, and in C, you do have to use your calculator. We're going to talk about why. Okay, so here's your triangle. And I'm going to fill that in. This is given to you as 20 degrees. And then this side is x, this side is 6. Alright, now this one we have to use the calculator for because it's not a 30, 60, 90 or a 45, 45, 90. Okay, and so our first step is going to be the same that we did for A and B. Okay, so from 20 degrees, this side is my adjacent side, this side is my opposite side. Yes, so with O and A, we have to use the tangent. So it's the tangent of 20 degrees. Whatever you are doing your sine, your cosine, or your tangent for, this has to be the degree. And now we're going to have 6 over x here. Now, this is different than the other two. Why? What is different? X is in the denominator. So remember before how we would multiply both sides by 20? Technically for this, to solve it properly with algebra, what would you have to multiply both sides by? Don't multiply by 6, because that would make it 36. If you did 1 over 6, it would just cancel out the 6's, but you'd still have 1 over x. So you have to multiply both sides by x. Don't write this part down, just pay attention to me, okay? So if you multiply both sides by x, that's the only way to bring this out from the denominator. So you have 6 times this, but to get x by itself, what would you do to both sides? Okay, so if you divide by the tangent of 20, look and see what your final equation looks like. Okay, what happens from this equation to here? Yeah, the x and the tangent, see how they switch places? Okay, that's always going to happen. So if x is on the bottom, you divide 6 by the tangent of 20 degrees. Okay? And I'm fine with you jumping from here to here. Okay, that's what the part that you have to write out. Okay, just like I'm fine if x is on the top, you go from here to multiply. So on the top you multiply, on the bottom you're going to divide. Okay? Now, if you just do this in your calculator, okay, you do 6 divided by the tangent of 20, and some of you might get this answer. How do I know that that cannot be correct for x? Yeah, x is longer, right? So 2.68 is shorter than this. We know this has to be longer, not just by sight, but because this is 20 degrees, what is this angle? No?
70,
because together they make 90, right? Because that one's 90. So remember the rule that says the side across from the larger angle is the bigger side from geometry? So because this is across from 70 and this is across from 20, this side needs to be larger. Okay? The only thing we have to do to fix this, and you will have to check this, even if you turn it into a mode, because every time you clear your calculator, it defaults back to what is called radians. So I need you to click your mode button, which is right here, next to the second. And then if you go down to the third menu, it says radians and degrees. How many of you have heard of radians before? You've heard of it. Okay, so if you're not sure about what radians are, a really simple way to think of it is temperature is measured in degrees Fahrenheit and degrees Celsius, right? We're on board with that. Angles, they have two measurements too. You can measure them in degrees or you can measure it in radians. So it's just another way to measure something that's the same, okay? So what we're going to do is we're going to select degree, so highlight it so it's blinking, press enter, okay, and then go to quit, and we're going to do that same equation again. Alright, now this is more in line with what we should see. We know that it's longer, okay, and then we're going to be rounding these to the nearest tenth for this section, so we'll start now. Okay, so you get approximately, it's like 16.48, dot. So if we round to the nearest tenth, this is about 16.5. So now, if you want to go back and try this for these, like the 74 sine of 30, you should get the same thing. Okay, and then you can try it for this one as well.
Is radians the space around the angle?
No, the radian is still the angle measure. So it's just like simply think of how temperature, you have 0 degrees and 32 degrees, like they equate to the same thing. It's just like that. You're measuring the same thing but in a different way.
What's the difference?
We will go over that in 10th grade. I'll give you the conversion rate.
Is there going to be a portion on our quiz that's no calculator?
We'll talk about that next week. Libby.
If you wanted to avoid doing that step, could you just find the other angle and then that one?
You said, could we avoid that by finding what?
Find the other angle and then that one
Oh, yeah, you can do the tangent of 70 equals x over 6. Yeah, absolutely. For all of these, you could find the other angle and do it that way. Okay? All right. Now, we are going to do some story problems. So we get to do some drawing. Something that you will have on your quiz is you will have to make sure that you do your drawing. Okay, that'll be part of like your points for it. So I want you to read through example 4. I'll give you 30 seconds of silence.